This is Algebra I, Section 9.3. We've been talking about quadratic equations. We learned in the past how to solve by factoring, but as we can see here, if I take my factors of 4, 1 times 4 or 2 times 2, there's no way that those are going to subtract to a value of 8. So we said we needed some alternative methods. All right, so in Section 1, we reviewed factoring. In Section 9.2, we talked about pure quadratics, and those were ones where the linear term was missing, okay? In that case, we subtracted the x squared and the 4, and we solved using the extract the square method. Now today in a 9.3, complete the square method kind of builds on the extract the root method. Now the way your textbook sets this up, 9.3 tells you the first half of the method. So here with 9.3 we will not actually be solving for x. We will just be learning the very beginning steps. Sometimes that's confusing to students because it's like we're learning the same thing twice. We're not. We're just learning how to do one piece of it and then we're going to put it together. Now this first piece is something you already know how to do. In fact, I gave you an assignment one day to build your own perfect square trinomials and factor them. So you've had a lot of practice with this and we're going to continue with that. So we're on page 315 right now, completing the square method. And let's just work with the problem that I already have up here on the board. Now, when we are factoring, we put this in standard form. We want to be in descending order by the exponent, and we want to be set equal to 0. But we're not factoring today because we've determined that this is not factorable. So we are going to use complete the square method. The first thing we want to do is separate the unknowns. Those are ones with variables because they can change from the knowns. Now the way I'm going to separate this is I'm going to add 4 to both sides. So now x squared plus 8x is equal to 4. My unknown values, my variables, are separated from my constant. We're still in descending order. Now remember, this is called the quadratic term because it's raised to the second power. This is the linear term because it's raised to the first power, and we have the constant here. Now, because the lesson is split, today we are only focusing on what happens on this side of the equal sign. So right now, we're not going to worry about this. And your text kind of goes ahead and gives you a sneak preview of what we're going to do, but that becomes a little confusing because they go all the way through it and then say, oh, we're not going to do that right now. So let's just focus on what we're learning today. What we're going to do today is make a perfect square trinomial. Okay, so to make a perfect square trinomial, we are going to take the linear term, we are going to take 1/2 of it, and then we're going to square that value. Now the steps are there on the bottom of page 315. Half the linear coefficient, so that's 8. I want to take half of it, so I can multiply by 1/2, or I can divide by 2. That's going to give us the same value, so whichever works for you. So we're going to take half the linear term and then we're going to square that value. So I'm going to stick with this. It's really much more efficient to divide by 2. We're going to take half the value and square it. So 8 divided by 2 gives me 4. And when I square 4, I get 16. That's the first 2 steps on the bottom of page 315. Find half the linear coefficient, the 8. I found half of it, and then I squared that value. I got 16. Well, what do I do with the 16? It tells us in step 3, add the square from step 2, back up here. So we're going to put this 16 and we're going to add it. Okay. Now, this is a perfect square trinomial which factors to a binomial squared. We're going to take the square root of the first term, the square root of the last term, and we're going to put the plus sign in. Okay. Now today, that's all you're going to do for the entire lesson. So if you look back through your examples on page 316, example 9.3a, at the beginning they give you x squared plus 10x. They didn't even give you an entire quadratic equation. They've just given you the quadratic term and the linear term. So we're going to divide the linear term by 2, and then we're going to square it, which gives me 5 squared or 25. I'm going to add 25, And then generally you'll be asked to factor that as well, which will be x plus 5. Again, we're using this sign. Remember the sign of the linear term. And we're going to square it. I did not finish up here. Remember, we have to square. Got sidetracked a little bit. Okay, so you can follow the results. Now, if you get to 9.3b, it becomes maybe slightly more confusing because instead of having a constant for the linear term, we have, well, we do have a constant, I misspoke, but it's not evenly divisible by 2. So here we see if we have 5 halves dividing by 2 and squaring, we're simply going to end up with 25 over 4. And that's going to be the value that we add here at the end as our constant. And then when we factor, again, we will take the x here, the square root here, and the square root here, and the sign. Now notice the value that we got when we divided this by 2 always ends up being the value here. So many textbooks, instead of writing it like this, will simply say x squared plus 5x plus 5 halves squared, rather than write out the entire 25 fourths. Okay, so that's up to you. I don't mind either way. The textbook kind of goes back and forth on it sometimes. Now, if you'll go on down to 9.3c at the bottom, this is where I tried to go a minute ago. We weren't quite ready for it. Now we have x squared minus 1/2 x. So when we take half of 1/2, we end up with a complex fraction. There's really no reason to do this because a complex fraction means we're going to put this over 1, we're going to invert it and multiply by 2 over 1, which is going to give us, not that. What did I do wrong? Divided by 2. Invert. I did not invert. All right. Okay, so 2 over 1. We're going to invert, and we will end up with 1/4, which is what we had. Well, we hadn't done it already, so we're going to add 1/4. And when we factor, we will take the square root here, the square root here, and this sign, all right, and square it, okay? But rather than go through this complicated mess of a complex fraction, you see the value here of simply multiplying by 1/2 that we talked about in the very beginning. We saw that we could either divide by 2 or multiply by 1/2. So my suggestion is anytime you have a fraction here for your linear term, rather than working with this complex fraction, just go right ahead and multiply it by 1/2 and use that value up here. So let's look at that particular idea one more time. This is, I think, number 30 in the homework problems. You have x squared minus m over 2n x. All right, so this is my linear term, m over 2n. Instead of dividing by 2, since it's a fraction, we're simply going to multiply by 1/2, which will give me m over 4n, which then will be the value that we put up here. We're going to add m over 4n squared. All right, or you can put m squared over 16n, but again, there's really no reason to do that. All right, keep losing my train of thought today. Sorry about that. Now, you will see in your textbook that because this is negative and because I'm squaring the negative, very often they will write it like this. There is no reason to put the negative here unless it just makes you feel comfortable, because what happens when we square a positive? We get a positive. When we square a negative, we still get a positive. So this little sign, that's up to you. It's really unnecessary. We're always going to be adding, because remember, perfect square trinomials always have positive squares, and this is half the product of the two values. All right, so that pretty much covers 9.3. Now in 9.4, the very next video, I'll explain how to continue on with this step to solve using the complete the square method. Thanks.